Hello everyone, it's Quick Flash, back with another video. Today I just wanted to answer a question that Brian White had about the new stick feels or stick PID code. I figured this might be useful for everyone else that wants to try the feature, use it, see what it does. So let's dive into it. So the stick feels code, let's just run through everything. So what's the purpose of this last RC command data? Well, purpose of last RC command data is because that is used to calculate the D term. It needs to see the previous and the current, RC command in order to find the change, the rate of change, which is how the D term works. And then I term, we gotta stick this I term in here so that we can have an I term that can accumulate over time per axis. So if you see here, I term for whatever axis it's currently on you see this plus equal means that it's I term axis plus I term low plus I term high. That's what I term now equals. So you're just adding the I term low and the I term high. So every time it loops through, the I term slowly accumulates and adds a bit more to fill in an error, just like on a normal PID controller. So what's the point of this if statement here? I can probably clean it up a little looking at it again, but as you can see, this if statement, it's basically saying if P low does not equal 100. Oh, did I do that wrong? Perhaps I have. Yeah, I think I've done that a little wrong. I'll be updating that, but no, I did that right. No. So if P low does not equal 100, you run this code. If P high does not equal 100, you run this code. If D low or D high, which I'll probably change the low and high to center stick and end stick because that's what they relate to. So if it's at center stick, if D is set to 0 and P is set to 100, then this code won't effectively do anything and it'll just waste CPU load. So instead it won't run unless some of those are active. Now these are just some parameters in the code to later be given values to help calculate things. RC command %, this literally, the RC command, the most it can be is 500. And so this just takes the RC command and makes it a kind of a % from 0 to 1. So it scales it from 0 to 1. The point of that is now we can do this low and high. And the low is just basically, the closer it is to center stick, the more it'll act like the low. And then the closer you are to end stick, the more it acts like the high. So whatever value you have for low, think of it as like that's center stick, and high is high. And then 50% is half, the average of low and high is halfway to the end of your stick. Fairly simple. So what does P do? So P, you can kind of think of it as, so P term in normal PID theory is it takes the error that you have. An error for our quads is generally, you have a set point of, say, 50 degrees per second and your gyro is only 40 degrees per second. So your error would be 10 and your P would push your motors more to try and get the gyro to match up. In this case, however, you can imagine that your set point, that your gyro read is always at 0, and that the P term looks at your RC command, or think of that kind of like your set point, it looks at that, and then it, based on what % you input into your P low or P high, that's the % that your P term will push the gyro, or in this case, the RC command to. So if your stick's P low is, say, at 80, then what it does is it makes your RC command equal to 80% of what your RC command actually is. And you may be thinking, well, hey, Quick Flash, what's the point of this? All you're doing is shrinking your set point or boosting your set point. I can just change my rates if I want to do that. Now, that is a decent thought. But if you look here, as you can see, the valid range of terms is between 50 and 150. So anything below 100 will shrink it, anything above 100 will boost it. But once again, what's the point if you already have your rates and you can just have different rates to change the stick feel? Well, that's where the I term comes in. Because you can see that the error is just the difference between the RC command and your P term plus your I term. So what your I term comes in and does is it looks at the error that was created because your P term didn't make it all the way to your RC command. It got close, but not all the way, or it shot past it. And then the I term says, whatever value you have for I term, think of it like a percent, same as P term, think of that as a percent. So if your I term is at 25, then every time this code gets looped through, every time your sticks get updated, it pushes your P term 25% closer to your RC command. So it takes as you can see, the error is based on this. And then you can see here that after the I term gets added, it's RC command plus your I term. So your I term will look at that error created here, see whatever that is, and if you have I set to 25, then every loop it gets 25% closer to filling in that gap. So if you want a looser, and maybe not looser is the right term, but you want a stick feel that's not as sharp, if you have a P term that's below 100 and an I term that's not super high, it'll take it a little bit for your rates to finally match what they actually are based on your stick position. Or if you want a sharper feel, you can set your PIDS, your P above 100, and have your I term whatever size you end up liking, and for a while your PIDS, your set point will be greater than what your stick is at, and it'll slowly come back down. So it can give you a temporary boost in stick feel if you just move the sticks real quick. So that's something kind of cool. So that's why you've got the ability to mess with this P term, is you can use it to smooth out your sticks even more, or you can use it to make them feel just a little bit sharper depending on what your P term values and I term values are. And think of I term as like whatever error your P term has created. So if your P term's at 80, then your stick command is only going to make 80%, and then the I term has to build up to fill in that missing 20%. And the higher your I, the quicker it'll fill in that percent. And then D term is probably the easiest one to understand, is it just fights change. So all the D term does, and once again you can see here, the only valid values for this are between 0 and 95, same for the I term. But it just fights any change in the RC command. So if you move your sticks and it changes RC command, the D term is basically look at it as the percent of change that it stops. So if you move your stick from 10% to 20% and you have your D low at 50, then it will fight half of that change and will only allow your RC command to go. You know, instead of from 10 to 20, it'll be 10 to 15 because it blocked half of that change. But in the next loop, if you keep your stick on 20, then it'll see that, oh, now half of 15 to 20 is 17 and a half. So it'll get you there, and it'll keep getting you. And so this here is really good at softening out abrupt stick movements, you know, having a set point that isn't filtered super great, so you get steppiness. This can like completely eliminate that as well and add this weird level of smoothness that you don't get otherwise. And so when I use it, I have my stick D low fairly high and my stick D high not nearly as high. I actually have maxed it out at 95 on my stick PIDS D low, and my high is about 30. So near the center stick, it really fights any move. It fights 90% of any of the change right near center. which is crazy. So it doesn't really allow much change at all. But as you know, this piece of code is ran, 100 times, maybe more, depends on your RC. But this piece of code's run a lot every single second. And so, you run it 10 times a second, and it can you can still get fairly quick movement. This can really just clean up and change your stick feel. So yeah, I just wanted to go over that and go a little bit more in depth, kind of answer a question that Brian White had, as well as hopefully answer anyone else's questions about this. Anyways, I hope that helped. Have a great day, everyone, and stay safe during all of this coronavirus stuff. Anyways, have a good one. Bye.